Have you ever imagined seeing the beginning of the universe as if you had a time machine for the cosmos? Well, now we can. The James Webb Space Telescope, or JWST, is unveiling secrets of deep space and showing us things we never dreamed of seeing. It's revealing ancient galaxies that are larger and more complex than we thought, stars born shortly after the Big Bang, and distant planets that might hold the ingredients for life. But how exactly does this change what we know about the universe? And more importantly, what does it mean for our future among the stars? Keep watching to find out how the JWST is rewriting the history of the cosmos and bringing us one step closer to answering the biggest questions about space. What is the JWST and what does it do? Imagine you have a super telescope so powerful it can see things billions of light years away, like having a pair of magical eyes. That's the James Webb Space Telescope, or JWST. It's like a giant telescope that lives in space. Being outside Earth, it doesn't have to deal with the atmosphere, which often blurs our view of the universe. This means it can see farther and more clearly than any telescope we have down here. The JWST is especially good at seeing infrared light, a type of light invisible to our eyes. Think of it like having night vision goggles for space. With this special vision, the JWST can peer through clouds of dust and gas that block other telescopes. It can observe things like stars being born, galaxies that formed soon after the Big Bang, and even search for signs of water and molecules on distant planets. In short, the JWST is like a cosmic detective. It helps us understand the universe's history from its earliest moments, uncovering secrets that were once impossible to discover. How has it changed what we know about ancient galaxies? Before the JWST started its observations, scientists believed the first galaxies were small, faint, and somewhat disorganized. They were supposed to be like seeds that would grow slowly over time. But the JWST showed us something very different. With its super detailed images, it revealed ancient galaxies that were already large and complex much earlier than we imagined. It's like finding a book full of beautiful words and sentences when you thought there were only scribbles on the first page. This means these baby galaxies had already formed billions of stars and were far more structured than we expected. The light from these galaxies traveled billions of years to reach the telescope, so we're seeing them as they were when the universe was very young, less than 1 billion years old. It's as if the JWST gave us a time machine to peek into the past. Because of this, astronomers are having to rethink how galaxies form and grow. Something different must have happened in the universe's early moments for these galaxies to be so developed. In other words, the JWST changed what we thought we knew about the universe's beginning, as if it rewrote the opening chapters of cosmic history. Did the JWST find stars older than we thought? The oldest stars in the universe are like cosmic fossils, relics from when everything was just starting. Before the JWST, the tools we had could only observe slightly younger stars. It seemed like the light from the oldest stars was simply out of reach. But then, the JWST came into play. Designed to capture infrared light that travels vast distances, it managed to spot the oldest stars we've ever seen. These stars formed just a few 100 million years after the Big Bang, when the universe was still very young. Imagine these first stars as the initial bricks used to build everything that came after. Now, with the JWST, we can look back in time and find out where these first bricks were. What's even more amazing is that the telescope not only found these stars, but also studied their composition. This helps scientists understand how heavier elements, like iron and gold, started appearing in the universe. In short, the JWST gave us the ability to see the oldest stars and learn from them. This is crucial for understanding the cosmos's history from the beginning and answering questions like, where did we come from? And how did it all start? How is the JWST helping us understand black holes? Black holes, especially the massive ones at the centers of many galaxies, have always been mysterious. They're regions in space where gravity is so strong that not even light can escape. Before the JWST, we knew these black holes existed, but it was tough to study how they grew and influenced surrounding galaxies. It was like trying to learn about a monster hidden in the dark without a flashlight. With its infrared vision, the JWST can better observe the areas around black holes. It can see how gas, dust, and even entire stars are pulled into these regions. Plus, the telescope showed us that many black holes grew incredibly fast in the universe's early days. They consumed matter at an astonishing rate, almost like cosmic devourers in the first billion years after the Big Bang. These observations have shifted our understanding of the role black holes play in galaxy formation. Now scientists can study how these invisible forces shape the universe and influence the creation of stars and planets. In other words, the JWST not only shed light on black holes, but also revealed how they helped write the cosmos's story. What have we learned about planet formation? Planets are born in giant clouds of dust and gas swirling around newly formed stars. Before the JWST, it was hard to observe these areas because visible light doesn't easily pass through the dust. It was like trying to see inside a sandstorm with sunglasses. The JWST, however, sees in infrared light, which can penetrate these clouds. With this, it revealed detailed images of so-called protoplanetary disks, the nurseries where planets begin to form. These disks are full of dust particles that, over millions of years, clump together to form planet cores. The JWST provided such precise details that scientists could identify regions where dust is gathering, taking the first steps toward becoming a planet. Plus, it showed that some of these disks have chemical compositions rich in organic molecules and water, ingredients that might be essential for life. What's most striking is that these observations also help us understand how our own solar system formed billions of years ago. By studying these space nurseries, scientists are uncovering patterns and features that likely occurred when Earth and the other planets emerged. This means the JWST is not only showing us how new worlds are born, but also helping us better understand our own origins. What new chemical elements has it found? The JWST has instruments that act like cosmic noses, able to detect molecules and elements billions of light years away. On planets outside our solar system, for example, the telescope has found signs of water, methane, and even carbon dioxide. This is a big deal because these molecules are some of the building blocks that could form the basis for life. Beyond that, the JWST observed new combinations of molecules in stars and gas clouds where planets are forming. This helps scientists understand what materials the first stars and planets were made of. It's like looking at the ingredient list of a very old cake to figure out how it was baked. These findings are hugely important because they show the universe is even more diverse than we thought. Every time the JWST discovers a new molecule or element, it helps us build a more complete catalogue of what exists in the cosmos. This also lets us compare different parts of the universe and search for places that might resemble our planet, increasing the chances of finding environments where life could exist. Why is this important for science and for us? The James Webb Space Telescope isn't just a scientific tool. It's a window into the universe's past and humanity's future. When the telescope reveals details about the first galaxies, stars, and planets, it's showing us how everything began. It's like reading the opening chapter of a book we could never open before. Understanding these early moments helps us answer big questions like, where did we come from? How did the universe form? What are the ingredients needed for life? But it doesn't stop there. The JWST also makes us look to the future. For instance, by studying exoplanets, distant worlds orbiting other stars, it helps us identify places that might be habitable. This is key if we ever want to search for life beyond Earth or even find a new home for humanity. Plus, The JWST's discoveries inspire people. Seeing images of giant galaxies, cosmic dust clouds, and ancient stars makes us realize how vast and wondrous the universe is. This can motivate future generations of scientists, engineers, and space explorers to keep unraveling the cosmos's secrets. In short, the JWST doesn't just transform science, it helps us find our place in the universe and dream of an even more exciting future.